In this video, we are going to discuss about the line codes. On the completion of the line codes, the students will be able to understand the properties of the line codes. So, line codes is nothing but it is a pattern of voltage, current, or photons that are used to represent the digital data that is transmitted over the channel, or it is transmitted in a storage medium. Here in the DC component, this eliminates the DC energy from the single power spectrum and enables the transmitter to be AC coupled. Mainly, this system can be recorded, and the transformer couplings are very less sensitive to the low frequency signal components. Hence, this low frequency component may last or it can be varied if the presence of the DC or near the DC spectral component is significant. And in the self synchronization, any digital communication system that requires bit synchronization, coherent detector requires this carrier synchronization. For example, if you are considering the Manchester code, it has the transition at the middle of every bit interval, that is at 0 or 1. When you are transmitting to the medium, this transmitter will provide a clocking signal at the each bit level. So in error detection, some of the codes will have the means of detecting the errors. That is, some codes such as the DO binary provides the means of detecting the data error without introducing any other error detection. It will automatically detect the error into the data sequence. Bandwidth compression, so this is mainly used for compressing the data with a specific bandwidth. So some codes such as multi-level codes that increases the efficiency is used for reduction in requiring the bandwidth so that more information can be transmitted through the channel. Power spectral density in NRZ. So NRZ is non-return to zero. This is the standard positive logic signal used in the digital circuit, which in the first state it is forces a high level, and in the zero state it forces a low level. And this refers to 1 or 0 in the form of voltage or current that is obtained by the specific properties of the physical channel. This selection can be used in one possibility, that is one possibility in clock recovery, and this clock signal is recovered by observing the transitions in the received bit sequence. So for a good recovery, this clock should be guaranteed and the signal should be self-clocked. So you can see that block diagram of that polar RZ core and polar NRZ code. In Manchester coding, it is nothing but it needs a clock and always a transition in the middle of the clock period. In the states 1, it is represented by no transition, and in the state 0 it is represented by the transition at the beginning of the clock period. In the Manchester code, each of the bit will be signified by at least one transition, and since it is self clocked, it means that accurate clock recovery from the data stream is possible. And in addition to this, DC component of the encoded signal is 0, so it allows the signal to be self-clocked and it carries the significant overhead, and there is essentially twice the bandwidth compared to the NRZ and NRSI encoding. So this is the timing of Manchester encoding. Thank you.